Swayam Prabha. Digital India. Educated India.
So, in my previous lecture, I just mentioned how to find out the factor of safety by based on assumed trial slip surface. Okay. So, we generally assume a trial slip surface and do the analysis, and there we can have two options, one undrained analysis and drained analysis, total strength analysis as C phi and C analysis. There actually we assume this trial surface and then and center, and based on that we have developed the expression for factor of safety, which is the ratio of resisting moment by disturbing moment. From there we get the factor of safety, and we a number of trial slip surface we assume, and finally find out where the factor of safety is minimum. So, when the factor of safety become minimum, then we consider that is a most potential failure surface, and based on that we recommend that is the factor of safety for that particular slope. And in that major thing is you have to assume slip surface, and at the same time you have to assume a center. So, that is a most important part in the analysis, and finding out center is a difficult task actually. And in fact, these are the methods, older method we used before. Nowadays, I will show you the methods what we use. They do not use this method. There are some other technique, numerical technique, which will come later on, but for the time being we are discussing this how this is developed, slowly progressed. For that purpose only we are saying those. So, if I want to do analysis by assumed slip surface, then you have to find out the center. So, how to find out the center? That is, there are number of methods, though whether you use or not now. So, I will just explain how to find out the center. So, let us see this one. You can see the center of the most critical circle can only be found by trial and error. You cannot find out confidently. Various slip circles being analyzed and the minimum factor of safety eventually obtained, and a suitable procedure is suggested in the figure. I will go to show the next figure. The center of the each trial circle is plotted, and the value. So, that means if there is a slope here, I will show in the next. If there is a slope, and I will take a center here, I will consider slip surface. So, after doing this analysis, I will find out what is the value of factor of safety there and write there. So, like that a number of them, center I will change and failure surface also I will change, I will get another factor of safety. Like that around this I will get a large number of points with different values of factor of safety, but we do not know which one is actually the most critical. So, when I get a large number of points where the points representing the factor of safety, and then finally, the factor of safety may be from 1 to maybe 1.56, and there are values in between, large number of values in between. Then what I can do? I can draw a contour of factor of safety of definite value. Suppose I will draw a contour of factor of safety 1.1, contour of factor of safety of 1.2, contour of factor of safety of 1.3, contour of factor of safety of 1.4, contour of factor of safety of 1.5, like that number of them I can draw. And then if I draw these, then we will typically if it is done correctly, we will find a particular pattern that you will have a elliptical shape of those contour, and that center of this ellipse will be the center of the critical slip surface. That is the thing we have to assume. So, based on that actually we do analysis. You can see the center of each trial circle is plotted and the value of the circle is written alongside it. That means, if I choose a point there, whatever factor of safety I get, I will write there. And after several points have thus been established, it is possible to draw contours of values which are roughly elliptical, so that their center indicates whether the center of the where the center of the critical circle will be. Note that the value of f is more sensitive to horizontal movement of the circle's center than to vertical movement. That means, if I choose here, I can change the center this direction or change the center this direction. That is what is mentioned. Note that the value of f is more sensitive to horizontal movement of the circle's center than to the vertical movement. So, little vertical movement, whatever change will be a little horizontal movement, it will give more change. That is why it is called sensitive. So, while doing this change, you have to change little this side, but it can change more this side. So, that is what this is. So, this is not this is easy to say or explain, but it is not so easy to do. So, there are some guidelines. That means, once you set this one, either you can go this side or this side, or you can go above or below, like that you can change number of points, and for each center of the circle you have to find out factor of safety, write down the value, then number of values you will get at different points, then finally you have to draw the contour. So, I will show the next slide what it is done actually. You can see here. So, this is the one. So, you can see that suppose 1 point we have got initially suppose a number of points, and finally, we have got a contour of 1.39, contour of 1.36 contour of 1.38, 1.36 and 1.35 maybe somewhere here, and the value maybe is there 1.39, 1.45, 1.5, there are number of values are there. So, finally, you could draw a contour of 1.36, 1.38, 1.35 something like that, and then you can see when you draw the contour it comes elliptical, and center of the ellipse become the center of the critical slip surface. So, this become the critical slip surface. So, that is actually finally once you get this one, you can analyze and find out the factor of safety. And now, to determine a reasonable position for the center of a first trial slip circle is not so easy, but a study of the various types of slips that can occur is helpful. So, that means, what people observe in the case of soils with angles of shearing resistance that are not less than 3 degrees, that means phi greater than 3 degrees. The critical slip circle is invariably through the toe. That means, if it is greater than, so your slope is there and there. So, through the toe, that means like this, and toe as it is for any soil if the angle of slope exceeds 53 degrees. So, this angle if is greater than 53 degrees, then always it pass through this. That is the one observation. And exception to this rule occurs when there is a layer of relatively steep material. That means, if there is a layer here, different material is here, then it can be different actually. If it is there, it can be different. If a steep material at the base of the slope, that means, if it is there, then in that case for the same condition whatever it was going through this, it may go here and tangential to this. So, I will show in the next slide. There is a layer of relatively steep material at the base of the slope, which will cause the circle to be tangential to the. That means, one is actually what I will draw two slopes. One is this and this. If phi greater than 3 degrees and beta greater than 53 degrees, then your failure is something like that. But if it is a slope something like this, and there is a material here, then your slope can be something like this, failure can be something like this. Okay. So, it will not reach there. So, that is what is shown in the next slide. Let us see that. And okay, next slide. And for cohesive soil with little angle of friction, the slip circle tends to be deeper. That means, if there is a slope here, there, here. So, generally it will be something like this, it will go deeper. Usually extends in front of the toe, that means it will go beyond that. So, it will deeper and finally, it will be reaching here. This type of circle can be of course be tangential to the layer of steep material. That means, if it is a material is there, again there is a 2 layer, then it goes deep, but it cannot, if the steep material, then it cannot go deeper, instead of it will be tangential to that. So, that I will show the next slide. You can see here, this is the normal. So, this figure actually does not look like a circular, but anyway, this side it is extended. So, this can be sorry. So, normally you can see, if phi greater than 3 degrees is a phi greater than 3 degrees and beta greater than 53 degrees, then it will pass through this and it will go like this. Okay. And if there is a layer steeper material at the base, then with the same condition, the failure will not come to toe. Instead of this, it will become tangential and it will become circular and reach above toe. It will be something like that. And when it is a cohesive soil with a very little value of phi, in that case your failure surface always will be go beyond this base level, and in front of failure will start in front of the toe. So, that it is here and it will be slightly deeper than this level. And again, if there is a another layer is present here, steeper material, then the tendency will be to go here, but tangential to this. Okay. So, these are the these are the various observation while doing the while assuming the slip surface for the analysis. So, how to start? So, you have to see the angle, slope angle, you have to see the phi, you have to see the cohesion, you have to see the base embankment material and the base material. So, like if based on those observation, whether you will assume this or this or this or this, that to be then, and then of course, you can progress further. So, this is the initial observation you have to keep in mind. Next thing is if it is a cohesive soil actually, then we can find out the center quite easily by a method proposed by Felenius. And actually, if there are different types of slope, suppose there slope type different type of 1 is to 0.5, 1 is to 1, 1 is to 1.5, 1 is to 2, 1 is to 3, 1 is to 5, and angle of slope is 60, this angle alpha and beta is given. That means, these two are actually provided by Felenius. That means, you have to do some construction. If there is a slope is given something like this, this is slope angle, and if this is the slope, then angle is 60 degrees. If this is the angle is 45 degrees, this is the slope, this is the angle. If this is the one, this is the angle. If this is the slope, this is the angle. So, these are the different slope angles. So, this angle is given, suppose, and then Felenius suggested a construction procedure based on alpha and beta to locate the value of phi. Locate the center. So, how to do that? You can see next slide we can go. This is the method. You can see this is the failure surface, this is the slope, and you can see you can locate toe and locate the end of the slope, these 2 points, and from this point you draw a line with the sloping surface at an angle alpha. This is the line with angle alpha, and again you can draw another line with angle with horizontal passing through the end of the circle with angle beta, and draw another line. So, this line should be drawn with beta from here, and this line will be drawn with angle alpha from here. So, these two lines once you draw, then they will definitely intersect at a particular point, and that point, actually intersecting point, will be the center for the most of the cohesive soil. And so, what is the value of alpha and what is the value of beta? So, that is actually given by the Fellenius. You can see in the previous slides, you can see when there is a slope, when the slope is 60 degrees, your alpha will be 29 degrees and beta will be 40 degrees. So, that means, if you have a slope like this, and this is the alpha and this is beta, this is beta and this is alpha. So, alpha. So, if it is a, this angle is this slope angle, this is actually 60 degrees, then this alpha become 29 degrees and beta become 40 degrees. Similarly, if it is slope angle is 45 degrees, then your alpha is 20 and 37, and if it is a slope angle is 33.8, then your alpha will be 26 and beta equal to 35. And if it is a angle is 26 degrees, then alpha equal to 25 and beta equal to 35, and if the angle is 18.4, then it is 25 and 35, and the angle is 11.3, then 25 and 37. So, like that, if I so for different values of alpha beta, the intersecting point, sorry, you can locate, and this is the point. So, this become the center of the trial slip circle, and then taking this one, and then you can draw the slip circle, slip surface, and then you can do the analysis. But when it is a sheep high soil, this method will not work, and for that there is another suggested method, another method proposed by Jumikis, I think, proposed, and that actually to do that minor modification to be done, and that modification is something like this. Based on the tabulated value of, based on this value, suppose this is actually slope angle, suppose theta, and based on theta corresponding alpha and beta you can take from Fellenius table, and you can draw this, this is beta and this is alpha. If I do, then I will get the center. Once I get this center, and for sheep high soil, what additionally I have to do, I have to locate a point from here at a depth 2 h. So, if this is the height of the slope h, so 2 h distance I will draw a line like this, and then from the toe I will also draw another line, vertical line at a distance 4.5 h. If the h equal to suppose this, then 4.5 h. So, this is the vertical line I draw, and this is the horizontal line I draw, and they are intersecting at this point. When they are intersecting at this point, then this new point is located, and this point finally joining to this original center of the slip circle. So, these 2 points when you join x and O1, x and O1, x and O1, and then after joining, and you can extend it. And after extending this, then actually for sheep high soil I will have, I will not have on this point, but I may have center somewhere. So, where it will be? I have to along this line, either this side or this side, I can change the location. Along that line only it will be there. So, I can select any point on this, and based on that again I can draw I can draw the different slip, and then I can do the analysis. So, this is the one. So, when it is a cohesive soil, there is a method for locating the center, and if there is C phi soil, then first you have to locate based on Fellenius the center, and second modification proposed by Jumke is what you have to do, you have to locate a point at 2 h below the surface of the slope and at 4.5 h from the toe of the slope, and then locate a point, and from that point you join the originally located center by Fellenius and join these 2 points and extend, and on that point you have the new center, modified center. So, that is the thing as described perhaps in the next slide. So, this technique is not applicable in its original form to the frictional cohesive soil, that means where soil is possessing both C and phi. That means, what we have done when the C soil we are getting by drawing a line from here and drawing a line from here, this is the for C soil. Okay. So, this is beta and this is alpha and given by the Fellenius, but when you this is applicable for that one, and then the same thing can be adopted by minor modification suggested by Jumikis. How to do that? If there is a the slope is here, and we have got original center here, and then I get at a 2 h distance somewhere here and 4.5 h somewhere. So, this is the point. So, this distance is 4.5 and this is 2 h, and then I will join these two line and I will extend, and along this you will have I can change the new center. So, that is what top of the slope and a distance 4.5 horizontally away from the toe of the slope, that means this direction, and the center of the critical circle O lies on the line x 1, this is O 1 and this is x on the x O 1 extended beyond O 1. So, A 1 to extend beyond, and the distance of O beyond 1 becoming greater as the angle of friction increases. So, from O 1 how far this center will be with the increase of friction, it will be also increasing. So, that is the new things to be considered. So, like this, so that means whatever approximate initial method, that when the pure cohesive cohesionless soil, that you will have a planar flip surface and different method of analysis I have mentioned, and when there is a C soil or C phi soil, I can assume the number of slip surface, and based on that I can do analysis and find out the factor of safety. And while doing this type of analysis, we need a trial slip surface with a center, and for finding out the center there are different methods. One method is that you find out, assume the center and find out factor of safety and number of them, and then find out a contour of that different values of factor of safety, and the center of all those contours become the final center of the method. And another alternative is to find out the for cohesive soil by using Fellenius method, and when it is a C phi soil, then modification suggested by Jumikis can be adopted along with Fellenius method to find out the center. So, with this these are the things finally required, and this method such a method can only be used as a means of obtaining a set of sensibly persistent trial slip surface when the slope is irregular, or when there are pore pressure in the soil, conditions are no longer homogeneous and the method becomes less reliable. That means, whatever method so far we have discussed, that means there is a slope like this, and first condition is homogeneous and there is no pore pressure, and then what we are doing? We are doing slip surface and consider the equilibrium and finding out the factor of safety. But when the slope is irregular, when slope will be irregular, you might be or most of us we open the newspaper, now and then we see that landslide. Landslide is what? Is nothing but slope failure. In the hilly areas, suppose the slopes are like this, okay, and during it is a significantly high slope, and during rainy season water will enter here, and because of that the pore pressure develop and many other things happens, and then this entire slope sometime will be sliding towards the toe. So, this type of irregular slope, suppose the hilly areas something like this type of irregular slope when there will be there, and any time if you do analysis you may not get the enough factor of safety, and particularly when during rainy season this because of the development of pore pressure, this slope become unstable. And when this so far whatever slope we have shown there is a smooth sloping surface with horizontal top surface, and at the bottom also there is a horizontal level surface. So, this may be the road level, this may be another road level, something like that. Whereas, in actual when you do the landslide analysis and all, then your geometry will no longer like this, and as a result this type of analysis will not be valid. And for this actually initially there was a method proposed by Jambu, and that Jambu actually taken whatever may be the slope. If the slope is something like this, if there is a slope, so something like this, suppose if the slope is something like this, and this slope we do not know how it will fail. So, there actually it can be taken some slip surface something like that. In that case we can do number of slice. We have introduced the method of slice, but that is not really a method of slice. There actually to calculate the only weight of this slice, we have only divided into number of parts. So, that was a graphical method. That means, if I divide into slice on the graph paper, and then by counting the number you can find out the area multiplied by unit weight, actually we got the weight of each slice, and then from each slice we got normal gravity force is like that, then tangential force is tangential, and then normal force. From there you have got T and N, sorry T here and N here, and then we have taken the summation of T and summation of N as a resistance and sliding force, and did the calculation. So, that is not really the your method of slice, but what Jambu suggested that you have to at any place and on the slope there is slice is taken, and equilibrium of the slice is considered. That means, slice is isolated, and then on that slice what are the forces. When I separate this force, there we have considered only this normal and tangent, and we have not considered at the slide slope. So, now Jambu actually suggested this two side forces. So, from this side and this side force will be different. So, considering the equilibrium, when we consider the equilibrium of this, then your whatever number of equation we have and whatever number of unknowns we have, actually it is number of unknowns are more, and because of this problem is indeterminate. But Jambu initially to solve this problem, what he has assumed for a small slice this force and left side force and right side force is equal, and based on that he has given a solution, and it was working well, and it was a quite tedious method, but quite accurate. It requires repeated calculation when it developed very early in 60s, and later on instead of doing repeated calculation with the when computer came, people program the method, and instead of doing repeated hand calculation, you can give the input information and program it, and through that program we can instruct the program to do the calculation repeatedly to find out the final value of factor of safety. That was one method. And there are actually, so in this method of course, the limitation was that he has considered the left side force and right side force is equal, but there are also Jambu and Bishop actually. Bishop's this is originally known as Bishop's slip method of slice, and then later on he has introduced modified Bishop, the Jambu's method, then there are many others, Morgenstern, many of them have suggested using this concept, and then finally their concept is program, and number of software now available to do the slope stability analysis. Whatever may be the slope, it is whether it is regular or irregular, whatever may be the height, whether there is a water flowing or whether it is dry, whether it is partially saturated, any condition you have, we can program it, and then we can get the final factor of safety. So, this is a somewhat advanced, and it requires lot of calculation, and it requires so much of calculation, it is not possible by doing hand, and nowadays at least no one will be ready to do that since computer is there. So, in fact, there are many ready-made program is available what generally people are using. So, our scope giving some introduction on program is out of our scope, but how this method works, some brief description I will give in the next lecture. Okay. Thank you. This.